Hello, my name is Young Eun Chi and I'm a Senior Research Fellow at the University of Melbourne. I'm going to try and give a brief overview on Project A1, which is about prioritizing management actions for biodiversity outcomes in streams and wetlands. So, when the area of management responsibility is almost 13,000 square kilometers, with more than 20,000 kilometers of waterways and nearly 70,000 water bodies, how do you decide where to give your attention? And given that there will always be budget constraints, how should we prioritize management actions across the entire region? Well, what do we need to know in order to take a systematic and strategic approach to prioritizing waterway management? Well, first we need to know what streams and wetlands we have in the landscape and which ones support important biodiversity values and ecosystem functions. We need to know what their present condition or status is and what threats they might face. And also, what management options are there for mitigating these threats? Which management options are likely to be most cost-effective? And finally, how can we show and share this knowledge with stakeholders to enable co-learning, feedback informed by local knowledge, and deliberation of priorities? In short, we need methods and tools to address these questions, means to comprehensively map and represent streams, means to estimate and depict their current condition and biodiversity value, means to characterize threatening processes and to explore threat scenarios, and means for comparing the outcomes of alternative mitigation actions. Now, people who have attended previous research fora or who have followed the development of Melbourne's Healthy Waterways strategy will know that this project has already developed tools to tackle the questions I mentioned and applied them in the course of supporting the development of the Healthy Waterways strategy. Now, what we want to be able to do is to do for freshwater water bodies what we did for streams and rivers. And I need to stress that this project focuses on freshwater water bodies because we do not actually focus at all on estuaries. So some of the research benefits of this project for Melbourne Water are that we will deliver fundamental spatial data for comprehensive and accurate representation of waterways and freshwater water bodies. We will be able to provide fundamental environmental data for characterizing conditions at waterways and water bodies and for use in ecological modeling. This project will provide the ability to model and characterize biodiversity patterns across Melbourne's waterways and water bodies. It will provide the ability to estimate impacts to waterway and wetland biodiversity from major threats such as climate change and land use change, such as loss of forest cover and increase of impervious cover with urbanization. It will also provide the ability to quantify the difference made by management actions with regards to mitigating threats. It will provide the ability to identify the most cost-effective management actions at any given waterway or water body. And it will provide the ability to spatially prioritize management actions across the Melbourne water region. And finally, it will give us the ability to map, summarize, and communicate all this decision-relevant data to different audiences. So methods for this project involve developing spatial tools for accurate mapping and representation, as you can see here, so that we know what it is that we have. We will also develop tools for describing environmental conditions and important influences on stream and wetland habitats. Now, a particular challenge has been characterizing water inundation and cover types at water bodies across the Melbourne water region. Like water inundation and cover types are really important for estimating habitat value, but also really difficult to characterize at landscape scales. So we and our La Trobe colleagues have been collaborating with Geoscience Australia and using the Digital Earth Australia tools to develop methods and models for using remotely sensed time series Landsat data to address this challenge. When we have a strong set of ecologically meaningful environmental data available, we will develop habitat suitability models for wetland-dependent biota, such as frogs and birds, so that we can predict habitat suitability at unsurveyed locations. We will also develop the inputs necessary for exploring threat scenarios, such as climate change projections and land use change projections. And critically, we will identify mitigating management actions and develop cost models for each of them, including understanding the factors that cause variation in costs when undertaking the same action in different locations. And finally, we will develop the suite of inputs required to run the conservation planning software tool Zonation that will help us identify spatial priorities across the Melbourne water region. So here's a highlight of some of the outcomes that have resulted so far. You'll find more outcomes in the research partnership prospectus document. Firstly, as part of continuous improvement in Project A1, we have developed an extended high-resolution stream network for the Melbourne water region that now includes headwaters. So these are the extensions in the areas with the dark blue background. This detailed mapping made use of LiDAR data acquisitions from 2009, 2016, and 2018. And as you can see from this detail, the hillshade model created from the LiDAR DEM has made it possible to detect and fix problems with stream alignments as well as missing headwaters. And the right panel shows how very detailed the stream delineation can be when you have access to high quality data. And we note that this stream network data is already being used to inform designated waterways policy. So if you like, you can learn more about the stream network from this particular link. We've also been working on developing a high quality, comprehensive water bodies spatial data set by compiling spatial data and attributes from more than 10 different data sources. And this was a big job, and bringing order to this compiled data set required lots and lots of corrective operations, including removal of spurious features, such as islands within water bodies, and removal of duplicated features. Sometimes we had to add missing features, as shown here, where this hillshade model was used to delineate a whole bunch of missing water bodies from this particular part of the landscape. It was also sometimes necessary to redraw or reshape water bodies, and then in its sort of tidy up, it was also sometimes necessary to amalgamate them. And finally, there was a whole bunch of cleaning and tidying and fixing typos and logical inconsistencies and augmentation of attribute data for the water bodies dataset. Now, we all know that for any given stream reach, its riparian zone, its immediate watershed, and its upstream contributing catchment area can all influence conditions that are experienced at that reach. Well, the same is true of water bodies. The catchment of a water body can also influence conditions at the water body. But generally speaking, it's pretty rare to have the appropriate data to be able to delineate the catchment of a water body. So this is really very rarely done at all. However, with our new stream network and high resolution DEM, we can delineate catchments for water bodies. And we think this is going to be both novel and very useful and valuable because it allows us to account for land use impacts within a water body's catchment. So for example, this figure shows the catchment areas that are associated with Turarong Reservoir. Turarong Reservoir has sort of multiple arms with the streams feeding into it. And our stream network and DEM has enabled us to properly and fully delineate all the areas that contribute at drain towards Turarong Reservoir. And we can repeat this for tens of thousands of the other water bodies in our dataset. And as I mentioned earlier, a particular challenge has been characterizing water inundation and cover types at water bodies. We've tried to address this by modeling water inundation and cover types using time series spectral data from Landsat. And we now have these first cut predictive models that look quite promising, as illustrated here in this example focused on wetlands of Cardinia Creek. Here's an aerial imagery of these wetlands. This is a classification of this image, and this is the predicted results from our model. So they look like they work. It looks like the model works reasonably well in our sort of testing data set. And what we need to do next is to extend these predictions across the whole of Melbourne water region and see how they perform. So for the coming year, we will continue to refine environmental and human impact variables for the stream network and update stream biota habitat suitability models where this is appropriate to do so. We will continue to develop the environmental predictor dataset for water bodies and use this data to develop first generation habitat suitability models for wetland dependent biota such as frogs and birds. We will also identify and develop candidate management actions for water bodies and develop a process-based understanding of the costs of these candidate management actions, as well as the factors that govern their spatial variation across the Melbourne water region. And finally, we will contribute to adaptive pathways planning for the Healthy Waterway strategy. And I'd like to acknowledge all the team members on Project A1, all of whom have contributed to make this project what it is. If you'd like further details about how Project A1 contributed to the development process of the Healthy Waterways strategy, there's a 30-minute talk that was put together for Melbourne Water's 20 Talks in 20 Days program earlier this year. And it's available at the YouTube link here. Or if you prefer something short and sweet, there's a Twitter thread I put together for the Greater Melbourne chapter of the Society for Conservation Biology Twitter conference earlier this year. Thank you very much for listening.